Okay, so this will be a short video. This one is just reviewing scientific notation, okay? Hi guys, it's something you've been doing probably as early as somewhere about probably in grammar school. I know it was practiced a lot in junior high and things of that nature. So we're just going to take a little bit of time here and practice this for a second. Put me some sample problems up here. Okay. So when dealing with scientific notation, usually a lot of times you got a really small number with a lot of zeros or a lot of numeral places, or a very large number with a lot of zeros in that case. Okay, scientific notation, is just a way of condensing those numbers into the measured powers of 10. Okay, so the rule of thumb basically with scientific notation is, okay, I'm going to write some sample ones up here. 0, 0, 3, 2, 1. Okay. All right. So obviously that's 2,400. Okay. So if we wanted to put that into scientific notation, okay, visualize this as if I put a decimal point right there. That does not change the value. That is still 2,400, 2,400, right? Okay. Right. By putting that there, that's just showing me where I want to start. Okay. So a simple starting point is when you have a whole number like so, okay, that is greater than the value of 1. Or if there's not a decimal point there already, which there wasn't, okay, that's what it would be if there was, I'm going to move the decimal point to the left, okay, until I'm between the first ones and tens place, okay, or the last two whole numbers in this case. So it'd be like this: 1, 2, 3. I moved it 3 places, so that makes it 2.4 times 10, and since I moved it 3 places to the left, that's going to make it a positive coefficient of 3, just like from the PowerPoint, but now I would just make it a simple bit. So 2,400 is the same as saying 2.3 times 10 to the third, okay? Simple scientific notation. Now, if I have one like this that has a value of less than 1, and where the decimal point is, I'm going to move the decimal point to the right until I get between the first two whole numbers. So right here, I'm going to go 1, 2, 3. I went 3 places there, till I got between 3.21 times 10, and I went 1, 2, 3 places to the right. So if I went to the right, that makes it a negative coefficient. Okay? All right? So that's 3.21 times 10 to the negative 3. Okay? All right? So that's when I have a whole number, and I got to put it in scientific notation, regardless if it's like that. All right, I'll do another one here. Let's do, oh shucks, let's do 17321.12. Okay, all right. I want to move this as far to the left between the ones and tens place. All right, that's a big number, so I go 1, 2, 3, 4. So that's 1.732112, and that sounds silly, times 10 to that moved it 1, 2, 3, 4 places. Okay, all right. If it's the value is less, like it is in this one here, if it was let's say it was 0.000001.2. Okay? I need to move this decimal to the right until I get between the first two whole numbers. 1, 2, 3, 4, 5, 6. So that'd be 1.2 times 10. Moved it to the right, negative 6. Remember, if I go to the right, it's going to be a negative exponent. Okay, if I go to the left, between the last two whole numbers, it's going to be a positive. Okay? All right, now let's take the reverse of that, and let's say I have scientific notation, and I want to put it into a whole number. Okay? Doing it both directions. All right, so let's say I have 2.41 times 10 to the 5th. Okay? And I ask you to put that in a whole number. Okay? That means make the big number. All right? So if I have 2.41, if I want to write it like that, I have 5 places, and since it's a positive coefficient, when I was going from a whole number to scientific notation, I go to the left for positive, but in this case, I reverse the rules. I'm going to move the decimal when I'm going from scientific notation to a whole number, and it's a positive coefficient, exponent, I'm going to then go to the right. So I'm going to go 5 places, 1, 2, 3, 4, 5. 0, 0, and 0. So now that value is 241,000 whatever. Okay? If I want to check my answer, then just convert it back to that. Okay, here's my decimal because I don't want to change the value. 1, 2, 3, 4, 5. 2.41 times 10 to the 5th. Same thing here as what I started with. This is the same thing here as I went to. Okay? So that's how you can check your answers if you want to. All right? All right, hopefully that all is coming back to you. It probably already came back to you without me doing this excerpt from the PowerPoint, but just want to make sure. A couple minutes of it, no big deal. And the same thing, let's take a negative value one. Let's do 1.34 times 10 to the negative 2. Okay? So now same thing, the rules apply here. I'm going to go to a whole number. So if I got 1.34, okay, and now it's a negative 2, all right, and I'm going to whole number, I'm going to go the opposite direction because it's going to get smaller, remember, because it's negative value. 1, 2. So the answer is 0.0134. I'm going to check my answer to see if I can get this. Just do it back. 1, 2, between the first two whole numbers, 1.34 times 10, because I went to the right, negative 2. Same thing, same way. Just a quick review of scientific notation, okay? Because we'll have some sample problems and stuff just to practice it, to get ourselves acclimated back to that as they come up with conversions and various other different equations as we have simple math in there, okay? Scientific notation, okay? All right, so that's it on that one. Only real quick and short to the point, showed you to go from whole number to scientific notation and back, okay? That's that.